Hello, how y'all doing? I'm Calvin Redmond. This is CSI 457 final project. So this basically shows how to extract learned images features from a pre-trained convolution neural network and use those features to train an image classifier or to train a classifier. Um, so I enjoyed the project. It was cool to have to like get something to work like that. Have the power have the power to control something like that just by training some images and having labels produce what those images are. So let's hop into it. So first we unzip it with with mergedata.zip, and then we're going to store those images in the image data store. So that's why the IMDS equals image data store merge data include the subfolders true and label source and the folder names. Then we're gonna split each label into 70 test 70 test strings and 30 test data. So 70% of the information will be training and the 30% is going to be test data, and that's also randomized. That's why we randomize there. That's going to store number of train images and randomly pull 16 train images from them. So that's how we set up the num train images, which equals num IMDS train.labels, and there are now 55 train images and then 20 validation images. And that's what those two lines of code are. And then you're gonna show the figure and the for loop. The for loop in the figure is what's gonna print out this image on the side. Kind of want to show that yet, but that's what's going to be displayed. Next, you're going to pre-train the ResNet network. Oh, also, I forgot to mention ImShow. You see that a lot and everything. Okay, anyways, so next we're going to do the pre-train ResNet network. So load it, and so you can do net equals ResNet 18. So this basically is a loaded pre-trained network. And so when you run it, you're going to see the properties, and you'll see the layers as well, and input names, which is data for right now, and output names for the predictions. Excuse me. Next, you're going to see the network architecture. The first layer is the image input layer, and it requires the input images to be size 224 by 224 by 3. That 3 is the number of the color channels. So once you have all that, a separate what's it called window will open, and it will show the analyst network of ResNet, and it's going to show all the layers and of course the final layer at the end. Okay. So next we have the extraction of the image features. Like we stated previously, the network requires requires input images of size 224 by 224 by 3. And to do this, to automatically resize the train and test images before they are input to the network, we're going to create augmented image data stores, and that's what these two variables I did to create. I did one for train, and I did one for the train images, and I did one for the test images. So these data stores are going to be used to input activations. So next is the activation in the global pooling layer, and this is layer equals pool 5. The network extracts a hierarchical representation of the input images. And so to get the features representing of the training and test images, you're going to use activations on the global pooling layer pool 5. And the global pooling layer pulls the input features over all spatial locations, giving a total of 512 features. I spelled giving wrong. Then you're going to do who's the feature train. So this is what's going to show when you run it. It's going to show the name, the size, the bytes, the class, and the amount of attributes. Okay, so next you're going to extract the class labels from the training and the test data. And so you're going to put those into variables, y train and y test. Next, we're going to you're going to fit the image classifier. So you use the features extracted from the training images as a predictive variable and fit a multi-class SVM using fit ECOC. Fit ECOC, yep. That's a statistics and machine learning toolbox. So once you make the classifier, you use the FICO features train ytrain. Both these two variables, the one from here and the one from above that. Next, you're going to classify the test images using the trained SVM model using the features extracted from the test images. So y equals predict classifier, and that's features test. You just did the one for the ytrain set as a classifier, so now you're going to do the test one as well. So this is kind of wrapping it up a little bit. So next you're going to display the 4 sample test images with their predicted labels. So first you're going to set a random variable index 1, 5, 10, 15. Those are going to be the random pictures that's going to be called. Random test images that's going to be called, I should say. And you're going to, like we did previously, you're going to get a figure. And so this will be figure 2 because we already showed figure 1. So this for loop is going to show 4 randomly selected images, 1, 5, 10, and 15. And it's going to show them to the screen. And from those 4 images, you're going to have different images, and those images are going to have labels. And if it's labeled correctly, that means it's correct. If it's not, then it's incorrect. So then you see the classification accuracy. The classification accuracy was actually 1, which means that's good. It returned the correct labels for each picture. So essentially that means the program worked. So now I will show you a demo. I actually have another example in this training a classifier on the shallower features. So that's like the earlier labels within it, but I don't know if I will have enough time to present that. So for now, we're just gonna, go with the initial project, and if I have time, I'll show the further learning I did because like I said, I was really interested in this. Okay, that's the end. So we're gonna scroll back up here. So first thing you're gonna do, of course, zip. Wait for that to load. Next, the image data store will label the images based on folder names and store the data in the object or as an object. Then the data is split into 70% training and 30% test data. So that's what the 0.7 is. So I'm about to show that right now. Whenever this, I don't know why it's taking forever to load. The internet connection is kind of bad. I don't know if I'm going to be going in and out. I should have said that when I started. But yeah, we're just gonna give it a second. Okay, so it's ready. I kind of want to show everything, but I don't really need to show this yet per se. So yeah, run that. We're gonna come down here with this matrix down here. Remember, this is the one gonna split the data 70 to 3, and for some reason I only end up copying and pasting some of it. That's not even the right one. All right. Okay. I kind of do want to show the split, just because, so yeah, it split. This number was not this before, and it definitely had more files located in it. I guess I should show the other one, but I don't think I'll have enough time for that right now. So I'm gonna keep on moving. So next we're gonna store the number of trained images and randomly pull 16 trained images. So just so you can see the number of images, I actually display this one in command window. So it's 55, like I already stated. So number of trained images is 55, and then randomly I'm going to pull 16 of them, and I'll also show this one too. So this basically just pulls out the array or the matrix, whatever you want to call it. I call it an array. So this pulls out the array 4, 37, 53, and these are the random 16 images that are going to be used and later on down the line. And pay attention to those numbers because you're going to see some of those numbers. So next we're going to get the figure for it. Copy and paste. And I'm going to enter. And if you look, it may take a second to load up. It's going to show, okay, it didn't take that long for once. Wow. Okay, so yeah, it shows all the figures. Well, not all the figures. Shows 16 figures, 4, 8, 12, 16. These are the 16 trained images. It's going to show 16 of them. So you can change that number around if you want to see, but for now, I'm working with 16. So after that, you're going to get the pre-trained ResNet network. You're going to upload it. I'll show you what that looks like. Though I don't really need to show you this one per se, but it's good to see what you're working with. So yeah, so this is the layers, the connections, input names, and the data, and the classification layer predictions. That's one of the layers names, I believe. We're gonna see when you analyze it. I don't know what I did here. I'm gonna say. So next we're gonna see the network architecture. The first layer requires input image 200 by 24 by 224 by 3. Like say before, the 3 is the number of color channels. So I'm just gonna grab this, copy and paste, come down here, print. Now you're gonna see a new window open up, and this is going to be the analyzer, the deep learning network analyzer. So you can see the activations, 224 by 224 by 3. See all this, and so then you see the last layer, the classification layer predictions. Yep, I was right. You can also look at it through here. I don't know why it's not pulling up like it did the last time, but so yeah, this shows the first layer all the way down to like the last layer, and you can kind of look at that. 71 layers in total. Next, we're going to have the extraction of image features. So this basically is going to, like I stated before, the network requires input images of size 224 by 224 by 3. But all the images in the image data store have different sizes. So this is basically going to be focused on, this next set of code is going to be focused on resizing them and test images before they are put into the network. And so we're going to do this by creating an augmented image data store and specify the desired image size and use the data source and input arguments to activations. Right? Okay, so this is augmented image data store for the train, and this is for the test, 55, 16. Remember those numbers. So let me print that and show you that. Right here, I'm running out of time. Okay. You know what? Just for, I will show these. So you can see what's really going on. So you see how the output size is now 224 by 224 because we're trying to get all the pictures to be the same size, instead of the random size that they are. Right? That's the goal. So we can see them looking organized. So next we're going to do activations on the global pooling layer. We're going to do this to get the feature representation of the training and test images. Activations on the global pooling layer, pool 5 at the end of the network, and then the input features over all spatial locations is 512 in total. Where's the mouse? Okay, let's see. I'm gonna come over here. Okay, and then you show the feature train, and then next you're going to put in a classifier using the multi-class SVM, and then you're going to display the images, 4 of them randomly, and then actually it's 1, and each picture is going to have a label either being a cat, screwdriver, or the playing cards.